my voice is audible to you all. Today, let me discuss the concept of argument of complex number. Yesterday, I discussed modulus of a complex number. Let me rub the board initially. Please give me 1 minute time. I will join with you now. Yes, let me discuss the concept of argument of a complex number. Argument or amplitude of complex number is nothing but the theta value, right? If z is equals to x plus iy is a complex number, then the principal value of z is given by alpha is equals to tan inverse of mod of y by x, which is nothing but the amplitude of z, and it is represented by theta. The argument of any complex number depends upon the quadrant in which complex number lies. If the complex number, that means while you are measuring, this is an argand plane, while you are measuring a complex number, while you are measuring the argument of a complex number, you should take two quadrants positive and two quadrants negative. If z is a complex number and if z belongs to first quadrant, theta is equals to alpha, which is equal to tan inverse of mod of y by x. If z lies in the second quadrant, then theta is equal to pi minus alpha. Why? Because if this is alpha, this becomes, this entire is 180 degrees. This entire is 180 degrees. Then it becomes pi minus alpha. Now, if theta is in the third quadrant, if z is in the third quadrant, then argument of z is equal to minus pi plus alpha. And if it is in the fourth quadrant, theta is equal to negative alpha, where alpha is equals to tan inverse of mod of y by x. Now, if I am writing here, what is the second point? The argument of a complex number depends upon the complex number in which quadrant it lies. Means if z belongs to q1, then theta is equals to alpha, which is equal to tan inverse of mod of y by x. If z belongs to q2, theta is equal to pi minus alpha. If z belongs to q3, theta is equals to minus pi plus alpha. If z belongs to q4, theta is equal to minus alpha, where alpha is equal to tan inverse of mod of y by x. You copy this one and along with the diagram, let us do some problems on this argument. To find out the argument of any complex number, first of all, you should check in which quadrant it lies. I hope you have copied it. Now let us do some problems related to arguments of complex numbers by taking 4 examples. Each complex number lies in the different quadrants. Okay. Now find the argument of the following complex numbers: 1 plus I minus 1 plus I minus 1 minus I 1 minus I. So these are the four complex numbers which are there in 4 quadrants. See, observe. If I want to find out the argument of this complex number, okay, first of all, you should consider z is equal to 1 plus I. We know very well that 1 plus I can also be written as 1 comma 1, right? This is x value and this is y value. Okay, therefore this belongs to which quadrant? Quadrant number 1. X is positive, y is positive. It belongs to first quadrant, right? Therefore theta is equal to alpha value, which is equal to tan inverse of mod of 1 by 1. In inverse trigonometric functions, you know that tan inverse of 1 value is equals to pi by 4. So the answer it is z, amplitude of z is equal to theta, which is equal to pi by 4. This is also called as argument or amplitude of a complex number. It is given by theta is equal to pi by 4. Now let me do this problem. Z is equal to minus 1 comma 1, which belongs to x negative y positive. X negative y positive means it lies in the second quadrant, right? Therefore theta is equals to pi minus alpha, means pi minus tan inverse of mod of y by x, means tan inverse of 1 upon minus 1. Pi minus tan inverse of minus 1 you are going to get, sorry, minus is negligible in the modulus. So you are going to get pi minus pi by 4 is equal to 3 pi by 4. This is the amplitude of that complex number. I repeat this problem again. Minus 1 comma 1, you can write this one as minus 1 comma 1, which is in the second quadrant. In the second quadrant, the amplitude of any complex number is pi minus alpha, where alpha value is equal to tan inverse of mod of y by x. Okay, so it becomes, in the modulus, minus is negligible. So pi minus tan inverse of 1. So tan inverse of 1 value is equal to pi by 4. You are going to get 3 pi by 4, right? Now, my question it is, if you won't take modulus here, see, that means a small error occurred previously, right? Even I have done a mistake by considering it as minus 1. See, if you won't take modulus here, okay, what happens? Tan inverse of, if you take only y by x instead of mod, you are going to get minus 1 here. You are having one fundamental in inverse trigonometric functions like tan inverse of minus x is equal to minus tan inverse of x. So at that time it becomes positive. So pi plus pi by 4 means pi plus pi by 4 is 5 pi by 4. 5 pi by 4 is 225 degrees, which lies in the third quadrant. See, the complex number will be in the, see here, the complex number will be in the second quadrant, but the angle you are going to get in the third quadrant if you won't take modulus. That's why you should take modulus here. So that is wrong now. That means wherever the complex, suppose the complex number is in the second quadrant, the terminal ray should be in the second quadrant. Okay, so if you won't take modulus here, it becomes pi plus pi by 4, which is equal to 225 degrees, which is in the third quadrant. The complex number is in the second quadrant, but the angle you are going to get in the third quadrant, that is wrong. Hence, you should take modulus here. It becomes positive. Hence, you are going to get pi minus pi by 4. 3 pi by 4 is a value which is in the second quadrant. Hence, it becomes right. And now, I am going to take this value z is equals to minus 1 comma minus 1, which belongs to quadrant number 3. In the third quadrant, theta is equal to, theta is nothing but amplitude of z is equal to minus pi plus tan inverse of mod of y by x, means minus 1 upon minus 1, which you are going to get minus pi plus pi by 4, which is equal to minus 3 pi by 4. This is theta value. Now itself I said, when you are measuring a complex number, you should take two positive quadrants, two negative quadrants. See, it is in the third quadrant, so it is negative 3 pi by 4 will be the angle. It is correct. Okay. Now, if I take z is equal to 1 comma minus 1, x positive, y negative, which is in the fourth quadrant. In the fourth quadrant, theta is equal to minus alpha minus tan inverse of mod of minus 1 by 1, which is equal to minus tan inverse of 1, which is equal to minus pi by 4. This is the. So, these are the four complex numbers which are in different quadrants, different four quadrants respectively. Therefore, we got different angles concerned to that. So, this is the way how to find out the argument of complex numbers. Copy these four problems. You copy those four. I conclude how to find out the modulus of, the argument of any complex number. First of all, you should check in which quadrant z lies. After that, according to that, you should take the angle. Yes, I hope you have copied it, right? Now, let us move to the next concept called polar form. What is called polar form of a complex number? What is called polar form of a complex number? Right? A point which is the polar form of a complex number is also called as mod amplitude form. Right? A point can be represented in three methods. One is Cartesian form, x comma y, which you know this one in your geometry, right? And the second one, it is vectorial form. That means in vectors you know very well. In vectors means xi bar plus yj bar, right? This same point can be written as a bar is equal to xi bar plus yj bar. If I represent this in by using x comma I bar comma j bar, then it becomes vectorial form of a point. That means point. This is called the Cartesian point. Cartesian form of a point. Now, the third one, it is polar form. If I represent a point by using parameters of a circle, what are the parameters of a circle? R, parametric equations of circle, r cos theta, r sin theta. That means if I use modulus, a point which is represented by using modulus and amplitude of a complex number is called polar form of that point. That means if z is equal to x plus iy is a complex number, right? Is a complex number, then r cos theta plus I sin theta is called polar form of a complex number. Polar form of a complex number, where r is equal to modulus of z, right? Modulus of z, and theta is equals to amplitude of z. Now the second point is r into cos theta plus I sin theta is also represented as r cis theta, right? So CIS theta means cos theta plus I sin theta. To find out, I am repeating these 2 points again. The representation of a complex number by using modulus and amplitude is called mod amplitude form or polar form of a complex number, and it is represented by r cos theta plus I sin theta, where you can also write that r cos theta plus I sin theta as r cis theta, CIS theta, means it is called as cos theta plus I sin theta, which consists of one real part and another and an imaginary part, right? Now you copy that one. Let us go through the problems of polar form. right? Now, how to write a point in polar form? Let me discuss two problems on this polar form. See here, convert, the question will be like this: convert root 3 plus I in polar form, or as this is objective, okay, the polar form of a complex number is, first of all, root 3 plus I. Let us consider z is equal to root 3 plus I, which is equal to root 3 comma 1, which belongs to the first quadrant. What is called polar form of a complex number? R cos theta plus I sin theta. R cos theta plus I sin theta is called as polar form of a complex number. So first of all, let us find out the value of R. Means R is equals to modulus of Z, which is equal to root of root 3 square plus 1 square, which is equals to 2. You got. Theta is equal to tan inverse of mod of pi by x, which is equal to 1 by root 3 is a value of pi by 6. So it becomes theta is equal to pi by 6. After that, you got R value and theta value. You substitute here. Root 3 plus I can be written as 2 into cos pi by 6 plus I sin pi by 6, which you are going to write this one as 2 cis pi by 6 is the polar form of that complex number. Copy this one. This is the way how to represent a complex number in the polar form. Yes. Let me go through another example of this polar form. Convert -1 minus I root 3 in polar form. See, first of all, z is equals to -1 minus I root 3, which you can write this one as -1 comma minus root 3 belongs to the third quadrant. X negative and Y negative, right? So this becomes obviously root 2, sorry, 2, right? Now this is tan inverse of theta is equal to, in the third quadrant, theta value is equal to minus pi plus alpha, means tan inverse of modulus of minus root 3 upon minus 1. So it becomes minus pi plus pi by 3, 60 degrees now. So you are going to get theta is equal to minus 2 pi by 3, right? So if theta is equal to minus 2 pi by 3, you are going to get -1 minus I root 3 can be written as 2 into cis of minus 2 pi by 3, which you can write this one as cos of 2 pi by 3 plus I into sin of minus 2 pi by 3, like this, right? And don't try to simplify this. Why? Because if you simplify this, you are going to get this one only. What is the meaning of this? We can also express -1 minus I root 3 as 2 into cis 2 pi minus 2 pi by 3 is the thing. Copy this one. I hope you have copied it, right? Now let us go. Actually, up to here, your CET ends. That means this is the syllabus of your CET level. Okay, up to here your CET problem. Now let us go through JEE main syllabus in complex numbers. The next concept in complex number it is, let us discuss the JEE main cube roots of unity. This is not there in your PU. Okay, cube roots of unity. What is the meaning of unity called? Unity is nothing but 1. So 1 power 1 by 3 cube root of unity. You don't know the value of cube root of unity. Hence I am going to consider it as x. Cubing on both sides, I am going to get x cube is equal to 1. X cube minus 1 is equal to 0. Right? Now this is in which form? A cube minus b cube. So you can write this one as x minus 1 into x square plus x plus 1 is equals to 0. Right? From this one you can write x minus 1 is equal to 0. X square plus x plus 1 is equals to 0. Right? From this one you can write x is equal to 1 is 1 root. As it is cubic equation, it consists of 3 roots. One is 1 you got, right? The first one is 1. And here x square plus x plus 1 is equal to 0 means you are not going to get the factors for this one, right? So x is equal to minus b plus or minus root of b square minus 4ac upon 2a. Right? So you are going to get minus 1 plus or minus I root 3 by 2. Minus 1 plus or minus I root 3 by 2 you are going to get. Am I right? Minus b plus or minus root of b square minus 4ac by 2a. So you are going to get minus 1 plus or minus. That means x value is equal to minus 1 plus I root 3 by 2 is one value which is called as omega, and x is equal to minus 1 minus I root 3 by 2 value is another value which is called omega square. Means 1 comma omega square are called as cube roots of unity. Right? These are called cube roots of unity, and the sum of cube roots of unity is equals to 0, which you got in your even. This is useful in your determinants also. Okay, and product of cube roots of unity, 1 into omega square value is equals to 1, which implies omega cube value is equals to 1. Okay, so you should note these 3 points regarding this cube roots of unity. 1 omega square are cube roots of unity. Wherever you got this equation, you can get this in terms of p, q, z, x like that. But wherever you got x square plus x plus 1 is equal to 0, p square plus p plus 1 is equal to 0, z square plus z plus 1 is equal to 0, then you can consider z value or p value or x value as omega or omega square. Understood? So these are the 3 points. 1 omega square are called cube roots of unity. 1 plus omega square. Sum of cube roots of unity is equals to 0, and product of cube roots of unity is equal to 1, which means omega cube is equal to 1. Tomorrow, let me discuss the other concept which is related to JEE main called De Moivre theorem. Right? Thank you and have a nice evening. Copy this one.